Welcome to the Wandering Mind, a quiet space for curious thinkers. Let your thoughts drift and allow the world to fall away.
As the first gentle light of dawn stretches across the horizon, softening the firmament of stars, we find ourselves poised on the threshold of a journey not in the traditional sense, but one that invites us to wander far beyond the confines of our earthly home and into the boundless expanse of the cosmos. It is here, in this vast arena of celestial wonders, that we begin our exploration of the largest things in the universe. It is a journey not only through space, but also through the realms of thought and wonder. Together, we will explore the largest structures in the universe, marveling at their scale and significance. In doing so, we may find that the universe, in all its vastness, has a place for us too.
In the quiet of a clear night, far from city lights, when the air feels crisp and the world around us seems to pause, we often find ourselves looking up at the sky, awash with stars. It is here, under this vast celestial dome, that we confront one of the most profound questions ever pondered by human minds. Is the universe infinite, or does it have an elusive boundary, hidden beyond our sight? The concept of infinity is both beguiling and bewildering. Philosophers and scientists alike have grappled with its implications. To imagine an infinite universe is to picture something that defies the very limits of our comprehension, a cosmos that stretches endlessly in all directions, with no edges, no end, just an eternal expanse of stars and galaxies. Yet, our understanding of the universe is grounded in the tangible and the measurable. We live in a reality shaped by dimensions and distances, where even the largest of numbers, when written down, have a definite end. So how do we reconcile this finite perception with the notion of an infinite cosmos? One way to explore this is through the lens of cosmology, the science that seeks to explain the nature and origin of the universe. At the heart of this field lies an age-old question: is the universe infinite, or does it possess a boundary that we have yet to perceive? For much of human history, the universe was thought to be both finite and centered around us. The ancient Greeks envisioned a cosmos enclosed in celestial spheres, with Earth at its heart. It was a comforting thought, perhaps, to imagine that the universe had an end, a place where the stars ceased and the heavens began. However, advancements in science have continually expanded our cosmic view. The heliocentric model proposed by Copernicus shifted our understanding, placing the Sun, not the Earth, at the center of our solar system. This was just the beginning of a series of revelations that would ultimately lead us to question the very size of the universe itself. Enter Albert Einstein, whose theory of general relativity provided a new framework for understanding the cosmos. According to Einstein's equations, the universe is dynamic, capable of expanding or contracting. This was a radical departure from the static universe model that many scientists of his time believed in. The idea of an expanding universe was further cemented by the work of astronomer Edwin Hubble. In the 1920s, Hubble observed that distant galaxies appeared to be moving away from us, with their light shifted towards the red end of the spectrum, a phenomenon known as redshift. This suggested not only that the universe was expanding, but that it might have begun from a single dense point, a concept that would later evolve into the Big Bang theory. The notion of an expanding universe raises intriguing questions about its size. If the universe is expanding, what is it expanding into? Here lies the paradox of infinity. In a way, the universe does not expand into anything. Rather, space itself is stretching. This can be visualized like the surface of a balloon being inflated. The galaxies are like dots on the balloon's surface, moving away from each other as the balloon grows. Importantly, the surface of the balloon has no edges, just as the universe, in this analogy, has no boundary. Yet, despite these insights, the question remains, can an infinite universe truly exist within our finite understanding? Some theories suggest that the universe might be finite, but unbounded, much like the surface of our balloon analogy, where one could travel indefinitely without encountering an edge. In recent years, cosmologists have introduced the concept of a multiverse, a theoretical framework suggesting that our universe may be just one of many, each with its own laws of physics. If true, this would redefine our understanding of infinity, placing our universe within a much larger, perhaps infinite, collection of universes. But how do scientists measure something so vast, so seemingly immeasurable? They rely on a combination of observational data and theoretical models. The cosmic microwave background radiation, a faint afterglow from the Big Bang, provides clues about the early universe's size and shape. By studying this radiation, scientists can infer the universe's curvature and potential extent. Moreover, the distribution of galaxies and the behavior of light around massive celestial objects offer further insights. Techniques such as gravitational lensing, where light is bent around massive celestial bodies, allow astronomers to map the invisible structures of the universe, hinting at its overall architecture. In our quest to understand whether the universe is infinite or finite, we find ourselves at the intersection of science and philosophy. Each discovery leads to new questions, reminding us of the vastness of the unknown. As we gaze up at the star-strewn sky, we are both humbled and inspired by the enormity of the cosmos, a universe that challenges our perceptions and ignites our curiosity. Whether infinite or finite, the universe is a testament to the boundless wonder of existence. It invites us to explore, to question, and to embrace the mysteries that lie beyond our current understanding. In this journey, we find ourselves not just as observers of the universe, but as participants in its ongoing story, forever seeking the edges of the infinite.
In the gentle embrace of the night sky, we find ourselves drawn to the scattered constellations, those ancient signposts that have guided both travelers and dreamers across the ages. Yet, beyond the twinkling stars that punctuate our evening vista, lies a much grander tapestry, the realm of galaxies. These magnificent structures, each a vast congregation of stars, gas, and the elusive dark matter, are the true titans of the cosmos. They stretch across the universe like shimmering islands upon a vast dark sea. Galaxies, in their multitude, tell the story of the universe's past, present, and future. Their varied forms, spiral, elliptical, and irregular, each have tales to tell. Spirals, with their graceful, swirling arms, bring to mind the tranquil motion of a cosmic dance. Our own Milky Way is such a galaxy, a spiral that gently rotates, taking our solar system along for the ride on one of its sprawling arms. The spirals are often the most visually captivating, but it is in the giant ellipticals that we find some of the most massive galaxies known. These colossal structures, elliptical in shape as their name suggests, are the ancient giants of the galaxy family. They are formed from the merging of smaller galaxies, a cosmic process that can take billions of years. In these mergers, the once orderly motion of stars is disrupted, creating a more randomized distribution, a stellar jumble, if you will. One might imagine these elliptical giants as the elder statesmen of the universe. Their light, often a little redder, hints at the older, cooler stars they contain. And yet, within these seemingly peaceful giants, there is often a hidden fury. Many house supermassive black holes at their cores, voracious entities that shape their host galaxies in ways we are only just beginning to understand. Among this extraordinary collection of galaxies, the largest known to us is IC 1101. Located over 1 billion light-years away in the heart of the Abell 2029 galaxy cluster, IC 1101 is a behemoth. It stretches over 6 million light-years across, a size so vast that it defies easy comprehension. If placed where our Milky Way resides, IC 1101 would envelop not only our galaxy, but also its neighboring ones, including the Andromeda Galaxy and beyond. The scale of IC 1101 is a testament to the grand processes that shape galaxies. Over countless eons, this giant has likely consumed many smaller galaxies, growing ever larger with each encounter. Such growth is not uncommon in the universe, where gravity's inexorable pull brings galaxies together, sometimes to merge, sometimes to pass by, in a gravitational embrace that can last millennia. Yet, even as we marvel at the enormity of IC 1101, it is worth reflecting on the more mysterious aspects of galaxies. Each one is permeated by dark matter, an invisible substance that does not emit light or energy and is detectable only through its gravitational effects. Dark matter is the scaffolding upon which galaxies are built, outweighing the visible matter by a significant margin. It is a silent partner in the universe's dance, one whose presence is essential yet enigmatic. As we ponder these island universes, it is tempting to consider the lives of the stars within them. Stars are born, live, and die within the shelter of a galaxy, their life cycles contributing to the galaxy's evolution. In spirals, like our Milky Way, new stars are continuously formed in regions rich with gas and dust. These stellar nurseries, often hidden from our view by the very material that creates them, are places of both beauty and chaos. In contrast, the elliptical galaxies, with their older stellar populations, present a quieter visage. Here, star formation has slowed or ceased entirely, leaving behind an assembly of stars that shine with a steady, ancient light. It is a reminder of the galaxy's own life cycles, from vigorous youth to a more serene maturity. The galaxies, in their multitude forms and sizes, invite us to reflect upon our place in the universe. They are reminders of the vastness that lies beyond our planetary home, each one a cosmic city teeming with stars, planets, and possibly life. As we gaze upward, we are connected to these distant realms, bound by the same forces that govern the cosmos. In the soft, contemplative hours of night, when the world is still, it is comforting to consider that we too are part of this grand tapestry. Our galaxy, the Milky Way, is but one of countless others, each a beacon in the darkness, a testament to the wondrous complexity of the universe. And as we drift into slumber, we carry with us the gentle hum of the galaxies, a lullaby sung by the stars. In the vast tapestry of the cosmos, galaxies are not solitary wanderers adrift in an endless sea. Rather, they congregate in vast assemblies, forming clusters and superclusters that stretch across the universe like sprawling cosmic cities. These clusters are among the largest known structures in existence, offering us a glimpse into the grand architecture of the cosmos. As we delve into this chapter, let us imagine ourselves gently floating through these celestial metropolises, observing the cosmic dance of galaxies coming together in intricate patterns. Our journey begins with the concept of a galaxy cluster. A galaxy cluster is a gravitationally bound group of galaxies, typically containing hundreds to thousands of individual galaxies. These clusters are held together by the invisible hand of gravity, the same force that keeps our feet firmly planted on Earth. However, the scale here is incomprehensibly vast. Within these clusters, galaxies orbit each other in a cosmic ballet, their collective mass warping the very fabric of space-time. One of the most well-known galaxy clusters is the Virgo cluster, our cosmic neighbor, located about 54 million light-years away. It contains roughly 1,300 to 2,000 galaxies, each a swirling storm of stars, gas, and dark matter. The Virgo cluster is part of a larger structure known as the Virgo supercluster, which, in turn, is but a small part of the Laniakea supercluster, a majestic entity that serves as our local cosmic address. Superclusters take the concept of galaxy clusters to an even grander scale. These are enormous assemblies of galaxy clusters bound together by gravity over hundreds of millions of light-years. Imagine a city with districts, each district bustling with its own vibrant communities. Within the supercluster, clusters of galaxies act as these districts, creating a cosmic web that stretches far and wide. One of the largest known superclusters is the Hercules Corona Borealis Great Wall, a structure so vast that it defies easy comprehension. Spanning approximately 10 billion light-years, this colossal feature challenges our understanding of the universe's scale and structure. To put it into perspective, light from one end of this supercluster takes billions of years to reach the other. Within this expanse, countless galaxies are nestled, each contributing to the cosmic tapestry. The discovery of such immense structures raises fascinating questions about the universe's formation and evolution. How do such colossal arrangements come into being? The answer lies in the primordial soup of the early universe. Shortly after the Big Bang, the universe was a hot, dense sea of particles. Over time, tiny fluctuations in this primordial soup led to the formation of structures, as matter began to clump together under the influence of gravity. These small perturbations grew over billions of years, eventually forming the galaxy clusters and superclusters we observe today. The study of these vast cosmic structures also provides insights into the enigmatic nature of dark matter. Though invisible to the naked eye, dark matter is believed to make up a significant portion of the universe's mass. Its gravitational influence is the glue that binds galaxies within clusters and superclusters, shaping the large-scale structure of the universe. Without dark matter, the cosmic cities we explore would not exist in their current form. As we wander through these celestial neighborhoods, we encounter the phenomenon known as gravitational lensing. This occurs when the immense mass of a galaxy cluster bends the light from more distant galaxies, much like a magnifying glass. This effect allows astronomers to peer deeper into the universe, revealing galaxies that would otherwise remain hidden. In this way, clusters act as natural telescopes, offering us windows into the distant part of the cosmos. The study of clusters and superclusters is not just an exploration of scale. It is a journey into the history of the universe itself. These structures are cosmic fossils, preserving the conditions of the early universe. By mapping their distribution and properties, astronomers piece together the intricate story of cosmic evolution, shedding light on the forces that shape the universe we inhabit. As we reflect on these immense cosmic cities, we are reminded of our place within the universe's grand scheme. The Earth, nestled within the Milky Way, is part of the local group, a small gathering of galaxies, which is but a tiny dot within the Virgo supercluster. Yet, even in this vastness, we find a connection, a reminder that we are part of something much larger than ourselves. And so, as we drift through this chapter of cosmic discovery, we find a sense of awe and wonder in the structures that define our universe. These clusters and superclusters, with their intricate beauty, invite us to ponder the mysteries of existence, to marvel at the forces that shape the cosmos, and to appreciate the delicate balance that allows us to gaze upon the stars. As our journey through the universe's grand architecture comes to a gentle pause, we carry with us the knowledge that the cosmos is both a place of order and chaos, simplicity and complexity, a true reflection of the wandering mind.
In the vast expanse of the universe, where stars twinkle like distant lanterns in an endless sea, there exists a structure so grand and mysterious that it almost defies comprehension. These are the cosmic filaments, the sinews of the universe, weaving a grand tapestry that binds galaxies together across unfathomable distances. Known as the Great Wall structures, these filaments form the very backbone of our cosmic architecture, a tangled web that stretches across the universe like the delicate threads of an immense spider's web. The concept of the cosmic web is a relatively recent development in the annals of astronomy, emerging from the shadows of theoretical physics and observational astronomy. Thanks to the pioneering work of scientists such as J. Richard Bond and Richard Gott in the 1980s, we began to perceive these filaments not merely as a curious phenomenon, but as a fundamental aspect of the universe's structure. At the heart of this revelation was the idea that galaxies are not evenly distributed throughout space, but rather clustered along these vast, interconnected strands. Imagine, if you will, the universe as a grand and intricate lacework, where clusters of galaxies are the beads, and the filaments are the threads connecting them. These cosmic filaments, sometimes stretching hundreds of millions of light-years, serve as conduits for matter, energy, and even galaxies themselves, guiding them along these predetermined pathways. Observations suggest that the majority of galaxies reside within these filaments, while the vast voids between them remain relatively empty, like the spaces between the threads of a delicate tapestry. One of the most remarkable examples of this cosmic webbing is the Sloan Great Wall, discovered in 2003 by J. Richard Gott and his team while analyzing data from the Sloan Digital Sky Survey. Stretching over 1 billion light-years across, it is one of the largest known structures in the universe, a testament to the grand scale upon which the cosmos operates. This Great Wall is not a solid entity, but rather a colossal aggregation of galaxy clusters and superclusters, interwoven by the invisible threads of dark matter. Dark matter, that elusive and enigmatic substance, plays a pivotal role in the formation of these cosmic structures. Though it remains unseen, its presence is felt through its gravitational influence, shaping the universe at every level. It is the scaffolding upon which the visible universe is built, dictating the formation of galaxies and guiding them along the web of filaments. Indeed, without dark matter, the universe as we know it would be unrecognizable, its very fabric altered beyond imagination. As we delve deeper into the mysteries of cosmic filaments, we are reminded of the intricate beauty of the natural world, both on Earth and beyond.
The filaments themselves are reminiscent of biological structures, akin to the neural networks of a brain or the delicate strands of a spider's web. This analogy is not merely poetic, it suggests a deeper symmetry between the microcosm and the macrocosm, a reflection of the universe's inherent elegance. Yet, despite their grandeur, these cosmic filaments are not static. They are dynamic and evolving, shaped by the forces of gravity and the expansion of the universe. Over billions of years, they have grown and stretched, drawing matter into their embrace and forming the galaxies and clusters we observe today. This ongoing process is a reminder of the universe's ceaseless motion, a cosmic dance that has been unfolding since time immemorial. The study of cosmic filaments and the Great Wall structures continues to push the boundaries of our understanding, challenging us to reconsider our place in the cosmos. They compel us to think on a grand scale, to appreciate the vastness of the universe and the complexity of its architecture. In the quiet moments of reflection, as we gaze up at the night sky, we may find comfort in knowing that we are part of this intricate web, connected to the stars and galaxies in ways that are both profound and beautiful. As we contemplate the Great Wall structures, we are reminded of the words of the poet John Keats, who once spoke of the beauty of the stars as the eternal dwellers of the sky. The cosmic web, with its endless filaments and sprawling walls, is a testament to that enduring beauty, a reminder that the universe is not merely a collection of stars and galaxies, but a vast and intricate masterpiece woven together by the invisible threads of time and space. In this vast cosmic web, we find both mystery and majesty, a reflection of the wonder that is the universe itself. As we continue to explore its depth, we are drawn ever closer to understanding the grand design that underpins our existence, a journey that is as infinite and boundless as the cosmos itself.
In the vast tapestry of the universe, there are threads that defy our understanding, weaving tales of mystery and wonder. Among these enigmatic entities are the black holes, often considered the giants of gravity. These cosmic titans hold a place of intrigue and fascination in the heart of astronomical study. Their presence is like a whisper in the void, a silent guardian of secrets too profound for the human mind to fully grasp. Imagine, if you will, a star much like our Sun, but significantly more massive. As it reaches the twilight of its life, this star undergoes a spectacular transformation. Consumed by its own gravity, it collapses inward, shrinking into an infinitesimally small point known as a singularity. Around this singularity lies the event horizon, the boundary beyond which nothing, not even light, can escape. This is the birth of a black hole, a region of space where the normal rules of physics seem to bend and warp. Yet, while these stellar mass black holes capture our imagination, it is the supermassive black holes that truly stagger the mind. These colossal entities sit at the heart of galaxies, including our own Milky Way, acting as cosmic anchors. The one at the center of our galaxy is known as Sagittarius A star, a behemoth with a mass equivalent to about 4 million suns. Despite its size, it remains shrouded in darkness, its presence inferred through the dance of stars and gas spiraling around it. The formation of these supermassive black holes is a topic of ongoing research and speculation. Some theories suggest they began as small seeds in the early universe, growing by accreting matter and merging with other black holes. Others propose that they formed directly from collapsing gas clouds, bypassing the intermediate stages. Whatever their origin, their existence raises captivating questions about the nature of the universe.
The influence of a supermassive black hole extends far beyond its immediate vicinity. It can shape entire galaxies, affecting the formation of stars and the distribution of matter. In essence, these giants act as sculptors of the cosmic landscape. Their gravitational pull influences the flow of galaxies like a maestro conducting a symphony. In recent years, our understanding of black holes has been significantly enriched by remarkable observations. In 2019, the Event Horizon Telescope captured the first ever image of a black hole's event horizon located in the center of the galaxy M87. This historic achievement provided a glimpse into the heart of darkness and offered new insights into the nature of these formidable objects. Black holes are not merely passive observers of the cosmos, they are dynamic, active participants. As matter falls into a black hole, it forms an accretion disk, a swirling maelstrom of gas and dust heated to extreme temperatures. This process can release enormous amounts of energy, outshining entire galaxies in some cases. Jets of particles traveling near the speed of light can be ejected from the poles, creating some of the most energetic phenomena in the universe. Yet, even amidst this activity, there are black holes theorized to be even more astounding. Consider the possibility of primordial black holes, born in the chaotic moments following the Big Bang. These hypothetical entities could vary in size from microscopic to massive, potentially providing answers to some of the universe's most persistent mysteries, such as the nature of dark matter. Moreover, the concept of black holes extends into the realm of the theoretical with ideas like the multiverse and wormholes. Could black holes serve as bridges to other universes? Might they hide within them the keys to understanding the very fabric of reality? These are questions that tantalize the imagination and push the boundaries of our scientific curiosity. As we drift through this narrative of cosmic giants, we find ourselves contemplating the delicate balance between light and shadow, creation and destruction. Black holes, with their immense gravitational pull, remind us of the power and mystery that reside in the universe's farthest reaches. They are a testament to the complexities of the cosmos, a symbol of the unknown that inspires both awe and humility. In the quiet contemplation of these celestial titans, we find a reflection of our own place in the universe. We are but small voyagers adrift in a sea of stars and galaxies, seeking to understand the vastness that surrounds us. Black holes, with their silent, commanding presence, challenge us to look beyond the visible, to ponder the unseen forces shaping our reality. And so, as we journey onward, let us carry with us the wonder of these gravitational giants, their mysteries as deep and profound as the universe itself. The universe is a grand, unfolding story, and black holes are among its most compelling chapters, inviting us to listen, to learn, and to dream.
In the vast theater of the cosmos, stars take center stage as the titans of fusion, performing a grand symphony of nuclear reactions. These luminous giants, scattered across the tapestry of the universe, are not just distant points of light, but colossal furnaces where the elements themselves are forged. As we drift towards understanding these magnificent entities, we find ourselves cocooned in a universe that is both ancient and ever-changing. Stars are born within the cool, dense nurseries of the universe known as nebulae. Here, within these vast clouds of gas and dust, gravity plays the role of an unseen sculptor. Over millions of years, it pulls and compresses until the conditions at the core of these forming stars become extreme. Temperatures soar, reaching astonishing levels, and the process of nuclear fusion ignites. Hydrogen atoms, the most abundant and simplest of elements, begin to fuse together to form helium, releasing energy in the form of light and heat, a celestial beacon announcing the birth of a star. The largest of these stars, often referred to as supergiants, are truly immense. Consider the star Betelgeuse, a red supergiant located in the constellation of Orion. If placed at the center of our own solar system, its outer layers would extend beyond the orbit of Mars, engulfing the inner planets in its fiery embrace. Yet, despite their size, these titanic stars live surprisingly short lives, burning through their nuclear fuel at an astonishing rate. As we ponder the life cycle of these stellar behemoths, we come to appreciate the delicate balance they maintain. A constant struggle between the outward pressure of nuclear fusion and the inward pull of gravity. This equilibrium is what keeps a star stable, but it is not eternal. When a supergiant exhausts its hydrogen supply, it begins to fuse heavier elements. The core contracts and heats up, initiating a series of fusion reactions that create elements like carbon, oxygen, and iron. Each stage in this stellar alchemy releases energy, but when iron forms, fusion can no longer sustain the star. Iron, unlike its predecessors, requires energy to fuse rather than releasing it. This marks the beginning of the end for a supergiant. Without the necessary outward pressure from fusion to counteract gravity, the core collapses in a matter of seconds. This catastrophic implosion results in one of the most dramatic events in the universe, a supernova. The outer layers of the star are expelled into the cosmos in a brilliant explosion, enriching the surrounding space with heavy elements. It is from the remnants of such starbursts that new stars, planets, and even life itself may eventually form. Yet even in death, a star's influence persists. The core, now a compact and highly dense object, may remain as a neutron star, or, if massive enough, succumb entirely to its own gravity, becoming a black hole, a singularity where the known laws of physics break down. The profound influence of these remnants echoes across the galaxy, shaping the very fabric of space-time and inspiring the awe and curiosity of those who study them. We find ourselves reflecting on the role of stars within the grand narrative of the universe. These titans of fusion are not just creators of light and warmth, but the architects of complexity. Every atom within us, every element that forms the world we know, was once cooked in the heart of a star. It is a humbling connection, reminding us that we are all, quite literally, made of stardust. As we lie beneath a blanket of night, gazing up at the stars, we are witnessing the history of the universe written in light. Each twinkle is a story of creation and destruction, of balance and change. And while the stars themselves seem eternal, their cycles remind us of the transitory nature of existence. There is a quiet beauty in their impermanence, a lesson in the fleeting dance of cosmic forces that shape our universe. In the gentle glow of understanding, we come to appreciate the stars not merely as distant suns, but as fellow travelers on this cosmic journey. Their lives, so different from ours in scale and scope, mirror the cycles of beginnings and endings that define our own existence. They illuminate the night sky, and in doing so, cast light upon the mysteries of the universe, and perhaps upon the mysteries within ourselves. And as we drift into the realm of dreams, let us carry with us the light of these stellar giants, the titans of fusion, whose stories continue to unfold, whispering secrets of the cosmos into the night.
As we drift deeper into the cosmos, our journey takes us to one of its most enchanting spectacles, the nebulae. These celestial marvels, vast clouds of gas and dust, are the stellar nurseries of the universe, where new stars are born. In these sprawling regions, the raw materials of the universe gather in an intricate dance, weaving the very fabric of the cosmos itself. Nebulae come in various shapes and sizes, each unique and beautiful in its own right. The word nebula itself, derived from the Latin for cloud or fog, speaks to their ethereal nature. Yet these are no ordinary clouds. They are immense, spanning light years across, and they play a crucial role in the cosmic life cycle. One of the most famous nebulae is the Orion Nebula, a bright and relatively close stellar nursery located in the sword of the constellation Orion. It is visible to the naked eye, appearing as a fuzzy patch in the night sky. Through a telescope, however, it reveals its true glory, a swirling, luminous tapestry of gas and dust illuminated by the young stars forming within it. The Orion Nebula is a mere 1,344 light-years away from us, a blink in the vast distances of the universe, yet it offers a window into the processes that have shaped our galaxy for billions of years. These nebulae are born from the remnants of older stars, which, after exhausting their nuclear fuel, shed their outer layers into space. This ejected material, rich in elements forged in the heart of stars, becomes the building blocks for new stars and planets. It is a beautiful cycle of death and rebirth, where the end of one star's life sows the seeds for new beginnings. The largest known nebula in our galaxy is the Tarantula Nebula, located in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. This impressive nebula stretches over 1,000 light-years in diameter and is an incredibly active region of star formation. Within its vast expanse, thousands of stars are being born, their intense radiation lighting up the surrounding gas and creating a celestial tapestry of colors and shapes. In these stellar nurseries, gravity is the artist, sculpting the clouds of gas and dust into dense clumps. As these clumps become more compact, they begin to heat up, eventually igniting nuclear fusion in their cores. Thus, a new star is born, and with it, the potential for new planets, moons, and perhaps, in time, life itself. The process of star formation is a slow one, taking millions of years, but it is a fundamental part of the universe's evolution. Each star that forms contributes to the enrichment of the cosmos, creating heavier elements through nuclear fusion and spreading them throughout the galaxy when it eventually dies. In this way, nebulae are both the cradles and the crucibles of cosmic creation, nurturing new stars and recycling the material of the old. Within the serene glow of a nebula, there is a quiet reminder of our own origins. The very atoms that compose our bodies were once forged in the heart of a star, born in a nebula like those we now gaze upon. It is a humbling thought that we are, in a sense, made of stardust, connected to the universe in a profound and intimate way. As we contemplate the grandeur of nebulae, we are reminded of the interconnectedness of all things. Each nebula is a chapter in the ongoing story of the universe, a testament to the cycles of creation and destruction that have shaped the cosmos for billions of years. In their beauty and complexity, they inspire awe and wonder, inviting us to reflect on our place within the vastness of space. The study of nebulae offers us a glimpse into the past, revealing the processes that have governed star formation since the dawn of time. By observing these distant clouds, astronomers can piece together the history of our galaxy, understanding how stars, planets, and eventually life itself came to be. And so, as we journey through the cosmos, let us take a moment to appreciate these magnificent stellar nurseries. Let us marvel at their beauty, their complexity, and their essential role in the grand tapestry of the universe. For in the nebulae, we find not only the seeds of stars, but the echoes of our own beginnings, a reminder that we are all part of something much larger than ourselves. As we drift along, carried by the gentle currents of the cosmos, let the light of the nebulae guide us, a beacon in the dark ocean of space. Let their stories of creation and transformation lull us into a peaceful slumber, as we dream of stars yet to be born and worlds yet to be discovered.
As we drift through the cosmos in our nightly contemplations, we reach a fascinating boundary in our exploration, the concept of the observable universe. Imagine standing on a quiet beach, watching the ocean stretch to the horizon. The sea appears endless, yet we know it isn't infinite. It's merely the limit of our vision. In much the same way, the observable universe represents the expanse of space that we can currently perceive. It's not the entirety of the cosmos, but rather the cosmic horizon that frames our celestial view. The observable universe is a sphere centered around us, extending roughly 93 billion light-years in diameter. This vast expanse encompasses everything we can see, from the nearest stars to the most distant galaxies. It is a realm filled with countless galaxies, each a bustling metropolis of stars and planets, all engaged in the silent dance of cosmic evolution. The light from the furthest reaches of this sphere has taken billions of years to arrive here, offering a glimpse into the distant past of our universe. Yet, as we stand at the center of this cosmic sphere, we might ponder what lies beyond our observational limits. The truth is, the universe itself extends far beyond this horizon, continuing into the unknown. The observable universe is limited by the speed of light, the fastest thing in the universe. Since the universe is about 13.8 billion years old, we can only see as far as light has traveled in that time. Beyond this cosmic horizon, the universe remains a tantalizing mystery, an uncharted territory waiting to be explored. This concept of the observable universe is deeply intertwined with the idea of cosmic inflation. Shortly after the Big Bang, the universe expanded at an astonishing rate, growing exponentially in a fraction of a second. This rapid inflation stretched the fabric of space-time, causing regions of the universe to move beyond our observable horizon. It's akin to inflating a balloon with tiny dots on its surface. As the balloon expands, some dots move out of sight, slipping beyond the edge of our vision. Our understanding of the observable universe is also a testament to the remarkable ingenuity of human observation and inquiry. Through the use of powerful telescopes and sophisticated technology, we've been able to peer deeper into the universe than ever before. Instruments like the Hubble Space Telescope have unveiled distant galaxies, revealing a universe teeming with activity and complexity. Consider the cosmic microwave background radiation, the afterglow of the Big Bang, which permeates the universe. This faint glow, detected by sensitive instruments, provides a snapshot of the universe when it was just 380,000 years old, a mere infant by cosmic standards. It is a whisper from the past,
a reminder of our universe's fiery beginnings. In contemplating the observable universe, we're also reminded of our place within this grand cosmic tapestry. We are but a tiny piece in a vast, intricate puzzle. Our galaxy, the Milky Way, is just one of billions, each with its own unique history and future. Yet, despite our smallness, we have the remarkable ability to look out into the universe and ask profound questions about its nature and origin. What lies beyond the observable universe remains one of the great mysteries of modern astronomy. Some scientists speculate that the universe could be infinite, stretching on forever. Others propose the existence of a multiverse, where countless other universes exist, each with its own laws of physics and cosmic histories. These are ideas on the frontier of scientific thought, where speculation meets the boundary of our current understanding. As we ponder the limits of our cosmic horizon, we are invited to reflect on the nature of knowledge itself. The observable universe is a reminder of both the power and the limits of human perception. It challenges us to continue exploring, to push the boundaries of what we know, and to remain curious about the mysteries that lie beyond. In the quiet of the night, as we gaze up at the stars, we can take comfort in the knowledge that we are part of something vast and wondrous. The observable universe is our window into the cosmos, offering a glimpse of the beauty and complexity that lies beyond our earthly confines. It is a reminder that the universe is not static, but a dynamic and ever-evolving entity filled with secrets waiting to be uncovered. So, as we journey through the night, let us cherish the view from our cosmic shore, knowing that beyond the horizon lies a universe rich with possibilities, a universe that beckons us to dream, to explore, and to understand. In the vast silence of space, we find not only the limits of our vision, but also the boundless potential of our imagination. As we delve into the boundless tapestry of the cosmos, there are threads that we can observe with clarity. Stars, planets, galaxies, these luminous beacons are the familiar landmarks of our universe. Yet, as we peer deeper into the cosmic ocean, we uncover an astonishing truth. The luminous matter, the stuff we can see and touch, is but a fraction of the universe's entirety. In fact, the grand majority of the cosmos is composed of entities that we neither see nor fully understand. These are the enigmatic realms of dark matter and dark energy, the invisible giants shaping the universe. Imagine, if you will, a grand theater where the visible actors perform under the spotlight. We marvel at their movements, their interactions, their brilliance. But unbeknownst to us, there exists a vast ensemble behind the scenes, pivotal to the narrative but concealed from view. This is dark matter, the unseen scaffold upon which the visible universe is hung. It does not emit, absorb, or reflect light, making it invisible to our telescopes. Yet, its presence is unmistakable. It exerts a gravitational pull, influencing the motion of galaxies and galaxy clusters, guiding their dance across the universe. The notion of dark matter first emerged from the observations of Swiss astronomer Fritz Zwicky in the 1930s. While studying the Coma cluster, a collection of galaxies bound together by gravity, Zwicky noted that the galaxies were moving much faster than expected. According to the laws of gravity, they should have scattered into the void, but they did not. To account for this discrepancy, Zwicky proposed the existence of unseen mass, which he called Dunkelmaterie, or dark matter. Though initially met with skepticism, Zwicky's hypothesis planted the seeds for a profound shift in our understanding of the cosmos. Further support for dark matter came from the work of Vera Rubin in the 1970s. Rubin measured the rotation curves of spiral galaxies, expecting to find that stars at the outer edges moved more slowly than those near the center, as dictated by Newtonian physics. Instead, she discovered that the stars on the outskirts moved just as quickly as those at the core. This surprising result could only be explained by the presence of an invisible halo of dark matter extending far beyond the luminous boundaries of the galaxies. While dark matter constitutes approximately 27% of the universe, its counterpart, dark energy, is even more prevalent, comprising close to 68%. If dark matter is the unseen architect of cosmic structures, dark energy is the mysterious force driving their expansion. In the late 1990s, two separate teams of astronomers made a startling discovery while observing distant supernovae. They found that the universe's expansion was not slowing down, as previously presumed, but accelerating. This acceleration implied the existence of a force counteracting gravity, a force we now call dark energy. The nature of dark energy is one of the great mysteries of modern cosmology. One hypothesis suggests it may be related to the cosmological constant, a concept introduced by Albert Einstein in his general theory of relativity. Initially, Einstein proposed the cosmological constant to achieve a static universe, which was the prevailing belief at the time. However, upon discovering that the universe was expanding, he famously discarded it, calling it his biggest blunder. Yet, in the light of dark energy, the cosmological constant has been resurrected as a potential explanation for the accelerating universe. Another intriguing possibility is that dark energy could be a dynamic field akin to an invisible fluid permeating space. This concept, known as quintessence, posits that dark energy's influence might vary over time and space, a tantalizing idea that continues to inspire and challenge theoretical physicists. Dark matter and dark energy, though unseen, are not without their fingerprints. They leave their mark on the cosmic microwave background radiation, the afterglow of the Big Bang. They shape the distribution of galaxy clusters and influence the large-scale structure of the universe. Their presence is felt in the gravitational lensing of distant objects, where light bends around massive clusters, revealing the hidden mass within. As we ponder these invisible giants, we find ourselves at the edge of knowledge, peering into a frontier as vast and enigmatic as the cosmos itself. The quest to understand dark matter and dark energy is not just a scientific endeavor, it is a journey into the philosophical realms of existence. What does it mean to live in a universe where the majority is unseen, where the forces that shape our reality are but whispers on the cosmic wind? In the quiet solitude of the night sky, as we gaze upon the stars, we are reminded of the profound mystery that envelops us. The universe, in all its majesty, is a reminder of our place within it, a place that is shaped not only by what is visible, but also by the unseen forces that guide us through the infinite expanse. As we drift into the realm of dreams, let us carry with us the wonder of the unknown, the curiosity that drives us to seek, and the gentle reminder that we are part of a cosmos filled with mysteries yet to be unraveled.
In the vast tapestry of the cosmos, there are objects so luminous that they outshine entire galaxies, blazing with the brightness of 1 trillion suns. These are the quasars, ancient and enigmatic beacons that illuminate the early universe, guiding our gaze across the depths of time and space. Quasars, or quasi-stellar objects, are aptly named for their star-like appearance when observed through a telescope. Yet, unlike stars, they are not mere points of light. Instead, they are the incandescent hearts of distant galaxies, powered by supermassive black holes. These black holes, with masses millions to billions of times that of our Sun, sit at the centers of galaxies,
their immense gravitational pull drawing in surrounding matter. As this matter spirals inward, it forms an accretion disk, a swirling whirlpool of gas and dust heated to extraordinary temperatures by friction and gravitational forces. It is here, in this cosmic cauldron, that the energy of a quasar is born. The disk emits light across the electromagnetic spectrum, from radio waves to visible light, and even into the realm of X-rays. This radiation is what makes quasars some of the brightest objects in the universe. To fully appreciate the brilliance of quasars, one must consider the distances involved. These celestial lighthouses are often billions of light-years away, meaning the light we observe today began its journey when the universe was in its infancy. Quasars are thus not only markers of the cosmos, but also time capsules, offering glimpses into the universe's formative years. The study of quasars began in earnest in the 1960s, when astronomers first identified these peculiar objects with the aid of radio telescopes. One might imagine the intrigue of this era, as scientists puzzled over the source of such powerful emissions. It was Martin Schmidt, a Dutch astronomer, who made the breakthrough. By analyzing the spectral lines of a quasar, he realized that it was not a star within our galaxy, but an object far more distant, its light stretched by the expanding universe. Quasars challenge our understanding of physics and the cosmos. Their very existence raises questions about the early universe. How did such enormous black holes form so quickly after the Big Bang? What role do they play in the evolution of their host galaxies? These questions remind us of the vast expanse of what we have yet to comprehend, a humbling reminder of the universe's complexity. Yet, as formidable as these phenomena are, quasars are not eternal. They are a phase in the life of a galaxy, active during a period when the black hole is voraciously consuming matter. Over time, as the available material is depleted or expelled by powerful jets of energy, the quasar dims, leaving behind a quieter galactic center. In our own Milky Way, the central black hole, known as Sagittarius A star, is relatively dormant, a sleeping giant that once may have burned brightly as a quasar. It is a tranquil reminder of the universe's dynamic history, where epochs of intense activity give way to periods of calm. Observing quasars requires the most advanced technology. Telescopes like the Hubble Space Telescope and the Very Large Telescope have allowed us to peer deeper into the universe, studying the light from these distant objects with unparalleled clarity. The upcoming James Webb Space Telescope promises to extend our reach even further, perhaps revealing secrets yet untold by these cosmic beacons. Beyond their scientific significance, quasars invite us to reflect on the nature of light and time. The photons emitted from a quasar's accretion disk travel across the universe, crossing vast stretches of space before reaching our telescopes. They are messengers from a bygone era, bearing witness to the universe's grandeur and its inexorable march through time. In the quiet contemplation of quasars, we find a narrative of contrast, the violent birth of light from the darkness of a black hole, the intense energy of a young universe juxtaposed with the serene emptiness of the cosmos. It is a story of creation and evolution, a testament to the forces that shape the galaxies and, by extension, the universe itself. As we drift into slumber, lulled by the slow, rhythmic dance of the cosmos, let us carry with us the image of these distant quasars. They are not merely objects of scientific inquiry, but symbols of the universe's boundless wonder, illuminating the dark expanse with their ancient light. In their brilliance, we glimpse the echoes of creation, a reminder of our place in the grand cosmic story.
In the quietude of the cosmos, where the vastness of space stretches beyond the limits of our imagination, there exists a gentle whisper from the dawn of time. This whisper, though imperceptible to our senses, carries the echoes of the universe's infancy. It is the cosmic microwave background, often abbreviated as CMB, a faint glow that pervades all of space, an afterglow of the Big Bang, which occurred nearly 13.8 billion years ago. The story of the cosmic microwave background is one of immense scale and profound significance. To better appreciate this, imagine standing at the edge of an ancient forest, where each tree represents an epoch of cosmic history. The CMB is akin to the soft ambient light filtering through the canopy, illuminating the path that leads us back to the very beginning. In the mid-20th century, scientists Arno Penzias and Robert Wilson stumbled upon this cosmic whisper quite by accident. While working with a large horn antenna at Bell Labs in New Jersey, they detected a persistent static that seemed to come from every direction in the sky. Initially, they suspected it was a fault in their equipment, or perhaps the result of pigeon droppings accumulating in the antenna, but thorough cleaning and testing revealed the noise was not terrestrial in origin. This serendipitous discovery earned them the Nobel Prize in Physics in 1978, for they had uncovered a relic of the Big Bang itself. The CMB is essentially the cooled remnant of the primordial fireball that birthed our universe. Today, it is observed as a nearly uniform background of microwave radiation permeating the cosmos. Its temperature is a chilly 2.7 Kelvin, just above absolute zero, a testament to the universe's cooling over billions of years. Yet, this cold expanse holds a wealth of information about the universe's early conditions. In these ancient photons lies a cosmic diary detailing the infant universe's density fluctuations. These minute variations in temperature and density, observed as tiny ripples in the CMB, are the seeds of all current structures, galaxies, stars, and planets. They are the primordial fingerprints that shaped the cosmos, dictating the celestial architecture we observe today. The study of the CMB has been likened to an archaeological dig, where each layer peeled back reveals a deeper understanding of our universe's formation. With missions such as COBE, WEMAP, and Planck, we have mapped the CMB with increasing precision. Each map a more detailed canvas of the universe's infancy. These observations have confirmed the Big Bang model of cosmology and have provided insights into the universe's composition, which is dominated by dark matter and dark energy. Dark matter, though invisible, interacts gravitationally and forms the scaffolding upon which galaxies are built. Dark energy, an even more mysterious force, drives the accelerated expansion of the universe. The CMB offers clues about these enigmatic components, allowing us to construct a more complete picture of the cosmos. As we contemplate the cosmic microwave background, we are reminded of the interconnectedness of all things. The light that began its journey nearly 14 billion years ago now bathes our world, a continuous thread linking us to the universe's earliest moments. It is a humbling thought.
that in the vast tapestry of the cosmos, we are but a fleeting pattern, yet woven into the very fabric of the universe. In our exploration, we find a profound sense of wonder in the CMB's gentle glow. It tells us about the universe's beginnings, its evolution, and perhaps its ultimate fate. It is a silent guardian of cosmic history, whispering the secrets of creation to those who listen. The cosmic microwave background is more than just an astrophysical phenomenon. It is a narrative of origins, a testament to the power of observation and curiosity. It calls to us from the depths of time, inviting us to ponder the grand questions of existence. As we gaze into the night sky, let us take a moment to appreciate this cosmic echo, a relic of the universe's birth that continues to light our path through the vast, mysterious expanse of space.
In the vast and intricate tapestry of the cosmos, there exist phenomena that challenge our very understanding of reality. Among these, gravitational waves stand as gentle whispers from the universe's grandest events. They are ripples in the fabric of space-time itself, stretching and compressing the universe in their wake, much like the ripples that spread across a pond when a stone is cast into its depths. To truly appreciate their significance, we must first delve into the very fabric of space, a concept woven into the fabric of modern physics by Albert Einstein over a century ago. Einstein's theory of general relativity revolutionized our understanding of gravity. Rather than viewing it as a simple force acting at a distance, Einstein described gravity as the curvature of space and time caused by mass. Imagine a trampoline with a heavy ball placed at its center. The surface of the trampoline curves around the ball. Now, if we roll a smaller ball across this surface, it will spiral inwards, mimicking the way planets orbit stars and moons orbit planets. This elegant metaphor helps us visualize the invisible dance of celestial bodies shaped by the contours of space-time. Gravitational waves, then, are ripples in this fabric generated by some of the most cataclysmic events in the universe. Consider two black holes locked in a cosmic waltz, orbiting each other in a frenzied embrace. As they spiral closer, they disturb the space-time around them, sending out waves that travel at the speed of light across the cosmos. These waves were first directly detected in 2015 by the Laser Interferometer Gravitational Wave Observatory, or LIGO, marking a profound moment in our exploration of the universe. With this detection, a new era of astronomy was born, one that listens rather than looks. The beauty of gravitational waves lies in their ability to reveal phenomena otherwise hidden from our senses. Much like the way sonar can map the ocean floor through sound, gravitational waves allow us to detect and study events billions of light years away, events that might not emit light in any form we can observe. They provide a unique window into the violent mergers of black holes and neutron stars, the latter being the dense remnants of supernovae, where matter is packed so tightly that a sugar cube-sized amount would weigh a mountain. These cosmic ripples also offer insights into the very early universe, moments after the Big Bang, when the universe was a hot, dense soup of particles. By studying the background of gravitational waves, scientists hope to glean information about the conditions of this infant cosmos, offering clues to the fundamental laws that govern our universe. In this way, gravitational waves are not just messengers of the distant past, but harbingers of a future where our understanding of the universe is ever more complete. The detection of gravitational waves is a feat of extraordinary precision.
The changes in distance that LIGO measures are on the order of 1,000th of the diameter of a proton. This is akin to measuring the distance to the nearest star, about 4.3 light-years away, to the accuracy of a human hair. Such precision is achieved through the use of laser interferometry, where laser beams are split and sent down long tunnels, reflecting off mirrors to interfere with each other. When a gravitational wave passes by, it alters the path lengths of the beams, causing a shift in the interference pattern that can be detected and analyzed. This technology showcases the remarkable ingenuity and determination of the human spirit in its quest to understand the universe. It is a testament to our ability to transcend the limits of our physical senses, to extend our reach into the universe through tools of our own making. And with each new detection, we learn more about the cosmic ballet of creation and destruction that plays out on scales both vast and minute. As we listen to the symphony of gravitational waves, we are reminded of our place in the universe. Each wave is a reminder of the interconnectedness of all things, a gentle nudge that we are part of a grand cosmic narrative. It invites us to reflect on the nature of existence, to ponder the mysteries that still elude us, and to embrace the wonder that comes with each new discovery. In the quiet moments of contemplation, as we drift into slumber, we might imagine these waves as lullabies from the universe, serenading us with tales of stars and galaxies, of black holes and the birth of space-time. They are a reminder that even in the vastness of space, where distances are measured in light-years and time in eons, there is a harmony, a gentle rhythm that binds us all together. And as we find comfort in this cosmic embrace, we can rest assured that the universe, in all its splendor, is a place of both awe and serenity. In the hushed corridors of theoretical physics, there whispers an idea so vast, so profoundly enigmatic, that it stretches the very fabric of our imagination: the multiverse. Imagine, if you will, the notion that our universe, with its vast stretches of galaxies, stars, and cosmic phenomena, is not a solitary existence. Rather, it stands as a single bubble in a grand cosmic foam, nestled alongside countless other universes. Each one may operate under its own unique set of laws, its own version of reality. The concept of the multiverse invites us to ponder a cosmos not as a singular entity, but as a boundless collection of universes. This idea, while tantalizing, is not a product of mere fancy. It emerges from the depths of scientific inquiry and theoretical exploration. One of the foundational pillars supporting the multiverse theory is the notion of cosmic inflation, a process proposed by physicist Alan Guth in the late 20th century. Inflation suggests that fractions of a second after the Big Bang, our universe underwent a rapid expansion, growing exponentially faster than the speed of light. This sudden inflationary burst, like a balloon swiftly inflating beyond its initial bounds, set the stage for the cosmos we observe today. However, what if this inflation was not a singular event? What if, elsewhere, other regions of space-time experienced their own inflationary episodes, birthing universes parallel to ours? In this framework, each universe might occupy its own bubble within an ever-expanding cosmic ocean. Within these bubbles, the laws of physics could vary, creating realms where the constants we take for granted, such as the speed of light or the force of gravity, might be altogether different. Such variations could lead to worlds that are strikingly dissimilar from our own, perhaps even unrecognizable. Another compelling hint at the multiverse comes from the realm of string theory, a theoretical framework that seeks to reconcile the disparate worlds of quantum mechanics and general relativity. String theory posits that the fundamental building blocks of reality are not point-like particles, but rather tiny vibrating strings whose oscillations determine the particle's properties. However, for string theory's elegant mathematics to hold, it necessitates additional dimensions beyond the familiar 3 of space and 1 of time. Some interpretations of string theory suggest that these extra dimensions could house entire universes parallel to our own, veiled from our perception. The notion of parallel universes also finds a home in the many worlds interpretation of quantum mechanics proposed by Hugh Everett III in the 1950s. According to this interpretation, every quantum event spawns a branching of realities, creating a multitude of divergent universes where every possible outcome of an event is realized. In this view, there exists an unfathomable number of universes, each tracing a different narrative, each carrying a different version of you and me. As we contemplate these theoretical constructs, we find ourselves wandering into philosophical territory. If the multiverse truly exists, what does it mean for our sense of uniqueness? Are we but one of countless iterations, each living out different possibilities? The multiverse challenges our understanding of identity, posing profound questions about existence and reality. Yet, it is important to remember that the multiverse, while an alluring and mathematically consistent hypothesis, still resides on the fringes of scientific inquiry. Direct evidence remains elusive, as these other universes, if they exist, are beyond our observational reach. We are bound by the limits of our own universe, confined to the dimensions we inhabit. Nonetheless, the exploration of the multiverse holds value. It pushes the boundaries of human thought, encouraging us to question the nature of reality itself. It serves as a reminder of the vastness of the unknown, of the mysteries that lie beyond our current understanding. In contemplating the multiverse, we engage in a cosmic journey, one that invites wonder and humility in equal measure. In this quiet reflection, let us consider the possibility that our universe is but one verse in an infinite cosmic symphony, each universe a note contributing to a grand harmonious melody that transcends the limits of our perception. As we drift into the gentle embrace of sleep, let us carry with us the wonder of the multiverse, a testament to the boundless curiosity that defines the human spirit. In the silence of the night, beneath the vast star-studded skies, the multiverse whispers its secrets, inviting us to dream beyond the stars, to imagine the unimaginable, and to find solace in the infinite possibilities that lie beyond our own universe.
As we gaze upwards at the night sky, the grandeur of the cosmos spreads out before us, offering a canvas as vast as the imagination itself. Each twinkling star serves as a reminder of the immensity of the universe and our tiny place within it. This contemplation of the heavens has fascinated humanity since time immemorial, inspiring both awe and a deeper inquiry into our place in the grand tapestry of existence. Imagine, for a moment, standing on a quiet hilltop under a clear night sky, far from the hum of city lights. The Milky Way stretches across the sky, its glittering band speaking of countless stars, each a sun in its own right, many with planets that may harbor their own mysteries. This is our home galaxy, a spiral of stars, gas and dust, gracefully rotating through the cosmos. It is also a reminder of how our tiny planet fits into this colossal structure. When we consider our place within the universe, we often feel small and insignificant. Yet, it is that very smallness that imbues our existence with a sense of wonder and curiosity. The vastness of the cosmos invites us to explore, to understand,
and to appreciate the beauty of the unknown. It is a reminder that while we are but a speck in the cosmic ocean, we are also a part of something much larger, something magnificent. Our understanding of the universe has evolved dramatically over the centuries. Early astronomers like Copernicus and Galileo reshaped our perception of the cosmos, moving us from a geocentric to a heliocentric view of the solar system. This was not merely a change in astronomical models, but a profound shift in how we perceive our place in the universe. The Earth was no longer the center of all things, but a part of a vast cosmic dance. The 20th century brought further revelations, as Edwin Hubble discovered that our universe is expanding, a finding that suggested the cosmos had a beginning, a moment now known as the Big Bang. This discovery opened up new avenues of inquiry, prompting us to ask questions about the nature of time and space itself. What came before the Big Bang? What lies beyond the observable universe? These questions are as much philosophical as they are scientific, inviting reflection on the limits of human understanding. As we ponder these vast scales and ancient histories, we might feel overwhelmed, yet there is comfort in knowing that our very atoms were forged in the hearts of stars. The iron in our blood, the calcium in our bones, the carbon in our cells, all were born from stellar nurseries and supernovae. We are, quite literally, made of star stuff, a phrase popularized by the late astronomer Carl Sagan. This connection to the cosmos is a poetic reminder of our roots and the interconnectedness of all things. Looking out into the universe, we see not only the past, but potential futures. The search for extraterrestrial life tantalizes us with the possibility that we are not alone. Projects like SETI, the search for extraterrestrial intelligence, scan the skies for signals that may indicate other intelligent beings. Although we have yet to hear that cosmic greeting, the search itself is a testament to our enduring curiosity and the possibility that one day we might discover that life, in its myriad forms, is a common thread woven through the cosmos. The enormity of space also offers a humbling perspective on our own lives. In the grand scheme of things, human conflicts and concerns can seem ephemeral. This does not diminish their importance, but rather places them in a broader context, encouraging us to focus on the shared human experience and the stewardship of our planet. The Earth, seen from the vantage point of space, is a delicate blue marble, a fragile oasis of life in an otherwise inhospitable universe. It is a reminder of our responsibility to care for this world and its future. With each new discovery, from the detection of gravitational waves to the mapping of the cosmic microwave background, our understanding of the universe deepens. Yet these discoveries also bring new mysteries and questions. What is dark matter, the unseen mass that holds galaxies together? What is dark energy, the force driving the universe's accelerated expansion? These enigmas remind us that the universe is not only vast, but also filled with secrets waiting to be uncovered. In contemplating the vastness of space, we are invited to embrace both the known and the unknown. It is a call to be explorers, thinkers, and dreamers. The universe, in all its immensity, is not just a backdrop for our lives, but an integral part of our story. It challenges us to expand our horizons, to look beyond ourselves, and to seek understanding and connection. And as we draw our gaze back from the stars to the world around us, we find that the true wonder of the universe is not just in its scale or complexity, but in its capacity to inspire. Each of us, in our own way, contributes to this grand exploration of existence. We are the storytellers, the seekers of truth, and the guardians of knowledge, carrying forward the flame of curiosity that has illuminated human progress. And in the quiet moments, when the night is still and the stars are bright, we can find solace in knowing that we are part of a continuum, a cosmic journey that began long before us and will continue long after us. Our place in the cosmos is both humble and extraordinary, a testament to the infinite potential of the human spirit.
As we draw near to the end of our cosmic journey, it is here, in the gentle embrace of the universe's vastness, that we find ourselves pausing for a moment of reflection. We've traversed the fabric of space, wandered among the stars, and floated alongside the colossal giants that punctuate the celestial tapestry. And now, in the quietude of this moment, we are left with nothing less than the profound silence of space itself, a silence that speaks volumes, if only we take the time to listen. The universe, in all its splendor and enormity, is not just a collection of distant objects and phenomena. It is a living, breathing entity, constantly in motion, ever evolving and endlessly fascinating. Each star, each planet, each swirling galaxy is a testament to the universe's creative force. And as we contemplate the scale of these wonders, we find a curious paradox. The larger the universe seems, the smaller we might feel, yet simultaneously, the more connected we become to the grand cosmic dance. Let us imagine for a moment the journey of a photon, born in the fiery heart of a distant star. It embarks on a voyage that will take thousands, perhaps millions of years to complete. This tiny particle of light travels through the void, crossing vast, empty expanses until it finally reaches the retinas of our eyes, allowing us to glimpse the ancient past of that distant sun. In this way, the universe tells its story, a narrative written across the cosmos in the language of light. As we lie back and gaze up at the night sky, we become part of this story. Each twinkling star is a chapter, each constellation a verse. The universe invites us to ponder its mysteries, to seek out its secrets, and to find our place within its boundless expanse. Yet, it also teaches us to embrace the unknown, to revel in the unanswered questions, and to find beauty in the very act of wondering. The vastness of space can be overwhelming, to be sure, but it is also liberating. It is a reminder that the universe does not demand understanding or mastery from us. Instead, it offers itself as a canvas for our curiosity, a playground for our imagination, and a source of endless inspiration. In this way, the cosmos becomes both a mirror and a muse, reflecting our deepest questions and igniting our most profound dreams. There is a certain serenity in accepting that we may never fully comprehend the universe's immensity, nor the intricate workings of its many wonders. Instead, we can take comfort in the knowledge that we are part of something greater, an intricate web of existence that binds all things together. In the grand scheme of the cosmos, our lives may seem but fleeting moments, brief sparks in the vast darkness. Yet each spark is part of the universe's story, a vital thread in the fabric of existence. In this way, we are all connected, not just to each other, but to the stars themselves. We are, as Carl Sagan so eloquently put it, star stuff, born from the remnants of ancient stellar furnaces, destined to one day return to the cosmic sea. As we drift into the gentle realm of sleep, let us carry with us the peace that comes from knowing our place in the universe. We are explorers on a journey without end, voyagers in a cosmos that is as beautiful as it is mysterious. The universe invites us to dream, to imagine, and to wonder, not just about the stars above, but about the infinite possibilities within ourselves. In this quiet, reflective space, We embrace the vastness of the cosmos, allowing it to fill us with a sense of awe and tranquility. We find solace in the knowledge that the universe is both our origin and our destination, a cosmic cradle that holds us gently in its embrace. And so, as we close our eyes and let the whispers of the stars lull us into slumber, we do so with the comforting thought that we are never truly alone. For in the grand theater of the cosmos, we are all players, each with our own part to play in the eternal dance of the universe. In this dance, we find our peace, our purpose, and our place among the stars.